So I'm going to build up the idea of trigonometric functions, so things like this, and I'm really going to build it from the ground up. So this lesson is going to differ from other YouTube explanations because in my explanation I'm going to build up using standard position on a graph, and then I'm going to show how the right triangle is formed. So standard position assumes that we have a graph like this, and then we have this initial side. And then I like swing this ray out to make a terminal side. And the terminal side can really end up anywhere. So I could have like here, or I could have like here. So whatever but that's what standard position is. So depending on your class, you might just define trig functions straight from a right triangle. You might not use the graph, but this is the way that my class works. And the ideas are connected. Just the way that my class works, we just kind of work from the ground up like that. So if you want to go straight to defining trig functions from a right triangle, I have another video on that, so you can look in the description. And if you're in my class, of course, just press on. So there's two things that we need to review. The first is the Pythagorean theorem. I'm assuming if you're in trig, you probably already know this. So you've got your two legs, and then you've got your hypotenuse, and you've got a squared plus b squared equals c squared. So this is going to be relevant for what we're talking about today. And then we also want to just talk about the distance formula. So the distance formula looks really tricky. So you've got like the 2 points P and Q. So this is x1, y1, and then this is x2, y2. And the distance formula looks like this. So it looks kind of tricky, and if you want to pause just to review it, if you need to review it, feel free to pause. The thing I want to tell you, the distance formula is really just the Pythagorean theorem in disguise. So just to show you this, like you don't really have to remember the formula in some ways. So let's say I've got my 2 points. So there's my P and my Q. So I want this distance between them, okay? So here's the deal. You can draw out kind of like this right triangle from that distance, okay? And then you can figure out what are these two distances. And to figure that out, this distance would be taking y2 minus y1, and this one would be taking x2 minus x1. So you get the two legs of what is now effectively a right triangle, and then we could just name those, you know, the legs of a right triangle. So now I can call this A, B, and C. And you probably already see how this relates to the Pythagorean theorem, but just to kind of draw this out. So I can use the Pythagorean theorem, a squared plus b squared equals c squared. Okay, so let's say I'm trying to find c, so I need to solve for c. To solve for c, I would take the square root of both sides, right? And I would get this expression here. And then I can just replace the a with the x2 minus x1, and I can replace the b with the y2 minus y1. So they're all connected, and that is the distance formula. So it's really just a special case of that. Okay, so understanding distance is going to help us with trig functions today and how we build our trig functions. And just what makes trig functions unique from like other functions that you've seen in the past is they start bringing in angles into the function, so they use theta. So this whole lesson is just going to like expose you to these functions and get used to the relationship between theta and then the ratio between the legs of the triangle. That's kind of what our goal is today, to kind of just get you used to how we set those things up and how we define those things. So we're going to do this with standard position. So first we're going to orient ourselves. So I start with a graph. I have my initial side. And so then I'm going to go ahead and just like imagine that I'm like swinging from here maybe out to this way. And so I'm going to get my terminal side like here. Okay, so when we do this, this creates an angle, and that angle is our theta. Okay, so that's our theta angle. And the other thing that I just want you to notice here is that I get a right triangle also out of this situation, and you're going to see these right triangles like all the way through trig now. So the right triangle, you want to think of it as being formed between the terminal side and the x-axis. So you're always looking for this. This is a thing you just want to get used to as you're learning trig functions, okay? So keep that in mind. We're going to come back to it in a second. So the first thing that I want to do is I want to figure out what is this length here from P to O. Let's call this R, okay? So the question here is, so how do you find R? Well, we were just talking about that, right? We use the distance formula. So you've always got a little bit of work in figuring this out when you're working with standard position. You've always got to figure out what R is. So I'm going to label this side as r, and then I'm going to do my work to figure this out. So I can figure out this distance by figuring out this distance here, x and y, right? Okay, so I want to figure out the distance between O and P, so I can do that using the distance formula. But one thing that I know about the point O is just 0, 0. So this x1 and this y1, I can just fill those in as zeros. So if I do that, check it out. I've just replaced a 0 here, and that actually simplifies this whole equation. So I'm just going to rewrite it now as x squared plus y squared. Let me make that y squared look a little more clear. Okay, so that's the first part. This gets us to our r. And the fact that we can find this distance here, and then we can also figure out these two, distances or lengths here. This is actually what's going to kind of motivate our triangle or our trig functions. And the last thing I want to tell you, so again, I'm just reiterating this. With standard position, the real thing that we're trying to do is we're trying to find these right triangles, and we're trying to label everything with them. So this is what really motivates our trig functions. We have to have the right triangle. This is just a thing you've got to get used to with this. So from the picture that we just drew, by creating our right triangle or by figuring out that right triangle, and then by having that angle theta, we get the 6 main trig functions. So I'll just show you what they are. Sine, cosine, tangent, cotangent, secant, and cosecant. So these are a big deal in a trig class, and each one has their own relationship between theta and the sides of the right triangle that we created. So let me show you how we define those relationships. And by the way, you'll also notice, so we actually abbreviate each one of these functions with just this 3-letter abbreviation. This is something that you're going to want to write down. This is something that's extremely important in a trig class. So you really have to have this memorized. So pause the video, write these down if you need to. These are just the whole point of this is just getting you used to these relationships. Sine of theta is defined by taking y over r. So I take the side of the right triangle, the y side divided by the r side. That is what it means to be the sine function. Cosine function is the x over the r. So this is how we define these for now, okay? And I want to make a notation note. I want to just kind of implant this in your brain before I go any farther. Sometimes you're going to see things like sine squared. I'm going to repeat this a few times, but I just want to start stating this now. When you see sine squared, that means that whatever you're taking the sine of 90 degrees, you're literally just squaring that. So doing that twice and multiplying it together. So just a notation note, getting you used to that now. Okay. So when you first learn the trig functions, kind of the whole idea then is to just get you used to those relationships that we just defined. So I'm going to show you some different exercises that can come up with this. So the first one is the terminal side of the angle theta in standard position pass through the point -12, -5. Find the values of the 6 trig functions of angle theta. Okay, so let's take a look at this. You're always going to want to draw a picture with these to really understand it. So I've got my point -12, -5. And so remember, the way that we think about this, if we're thinking about standard position, first we start with the initial side. So I've got this part here, and then I kind of swing it around, right, to get to the terminal side. So we always think about working this way. I get this terminal side, and then the terminal side is always going to create this right triangle. And so now I have to figure out, how do I label the sides of the right triangle? And so this is a little counterintuitive in some ways, but one thing that you have to do when you're doing this, you want to respect the negativeness of the points, okay? So the way that you're going to label this might be a little surprising. And then after you find those points, you also still have to find r, okay? So, all right, let's actually start by first figuring out what is r. So I'm going to take just a little bit of a shortcut with this calculation. So I'm just going to take, so I know this side is 12, I know this side is 5. So if I just want to figure this out, I kind of shorthanded the calculation here. So if I go through and I just kind of figure this out, what I will get is, I will eventually get to the square root of 169, which is just going to give me 13. So my r in this case here is 13. So your hypotenuse of your right triangle, when you figure this out, this is always going to end up being a positive number. But here's the weird part, like I was kind of trying to prep you for before. What do you do with the other sides? Okay, the way that you think about these is you actually have to bring in the negativeness of the points. You have to respect that for the other two sides. So the way that we're going to interpret this side here, I'm going to call this negative 12, not 12, negative 12. And then this side here, I'm going to call this negative 5. So we're doing that because that is actually going to help. That gives us some information. The reason that we want to keep these legs negative is that it gives us some information about that theta that we created, right? So this would be, remember, I start here and then I would swing kind of all the way around to the terminal side. This is a very large theta, and the way that I can kind of figure that out from the context of the problem is by keeping these points negative. So just kind of keep that in mind. I think that's something that can throw you off if you're thinking that these just mean distances. Okay, so what I'm going to do next now is I'm going to just create, or I'm going to set up kind of my ratios in this situation. So all you have to do then is you have to just kind of repeat that list that I had from before. Sine of theta is equal to y over r. So notice how I've labeled this whole thing. Now this is just like plug and chug. So y is negative 5, r is 13. So over here, I'm just going to plug those in. Boom, that's it. And that's all you have to do, like when you actually get to the trig functions. So you figure out how to label the sides of the right triangle that you create from standard position, and then you just plug it in. That's really it. So that's like the whole, like you getting used to these new relationships. So now I've got cosine of theta is x over r. So if you just take a look at this, so x is negative 12, r is 13, so this will be negative 12 over 13. And then tangent is y over x, so this will be negative 5 over negative 12. So the negatives will cancel out, so you just left with 5 over 12. Okay. Continuing on, we've got cosecant. This is going to be r over y, so it's 13 over negative 5. 13 over negative 5. Secant is r over x, so secant of theta is r over x, so that's going to be 13 over negative 12. And then finally, cotangent of theta is x over y. This will be 12 over 5. So one thing I want to point out too, like as you're getting used to these are just the straight up definitions of these functions. But notice cosecant is r over y and sine was y over r. Secant is r over x, cosine was x over r. So there is a relationship between some of these functions, like being inverses of one another, or sorry, reciprocals. Okay. So that's the only example I'm going to do like that in this video. I have more examples like that in another video. I want to show you some other types of examples of how this can present itself. So similar idea. Find the 6 trig, this should say trig function values. I flip-flopped the words. Find the 6 trig function values of theta in standard position if the terminal side is defined by this function here, x is greater than or equal to 0. Okay, so just to go through this, you always want to draw a graph with these types of problems. You want to orient yourself. So first things first, I need to draw my 3x plus 5y equals 0. So I'm going to rewrite that into slope-intercept form because it makes my life easier. So if I just solve for y, I get negative 3 over 5x. So, okay, I have graphed negative 3 over 5 here. And remember, x has to be greater than 0. So if x is greater than or equal to 0 only, it's going to start here at 0, and this is the greater than direction. Anything over here would be x, the x's would be less than 0. So make sure that you've got your picture right, okay? Now, consider where the initial side starts here. The initial side would technically start over here. And then remember, with standard position, I would go this way. So I'm going to have like this very large theta. And I just want you to take note of, like, start noticing this pattern here. I know you just learned this, but this very large theta, how does that impact whether our trig functions are positive or negative? Because that's kind of where this is going. Now, one other thing I want to say here. So note that no point was given. So in like the last exercise that we did, we had a point where this terminal side was going through, and we were using that side to kind of help like create that triangle. So what do you do if there's no point specifically given? I put this point here as I kind of noted out the slope, but no point has been specifically given in this situation. Well, when this happens, you just choose one. And you're going to see that this becomes kind of a handy approach. So I'm going to choose this point, the one that I already drew. So I'm going to choose this one because, you know, it's very easy to make calculations with. I already kind of plotted it. So don't go too crazy with choosing your point. Try to find something easy. And if you're just plotting, you know, if you're just creating a line anyways and you have a slope, you can probably just use the point from that slope. No reason to make it harder than it has to be. Okay, so I've chosen my point and I've got this situation here. So what we want to do now is we want to note, first of all, kind of the point that I've gone through and noting how that kind of impacts the sides here. So this side here, I'm going to call this as x equals 5. Since my point has a negative y coordinate, that's going to be reflected in the side. So my y here is going to be equal to negative 3. And then I can go through and I've got to find r, of course, right? So if I go through and I find r, go through and just, you know, do the math. I probably should have squared this as negative 3, but 3 squared and negative 3 squared are the same thing. So sorry, I was a little sloppy with notation. But anyways, as I continue on, so I get the square root of 34. So I get r is going to be equal to the square root of 34. Okay, so now that we've done all of this, now we can move on to the trig function values. So starting with sine, so sine of theta is going to be y over r. So if I just take my sides then, my y here was negative 3, my r was the square root of 34, so I've got negative 3 over the square root of 34. Now one thing I want to mention here is that we have to rationalize this. So I have a review video on how to rationalize if you need a reminder on that, so check the description of this video. But to rationalize, it's pretty simple in that you just multiply, when you have square roots, you just multiply this by the square root on top and bottom. So this would be the same thing rationalized, okay? So let's move on to cosine of theta. So this is going to be x over r. So my x is 5. My r is the square root of 34. So it's going to look like that, except I have to rationalize once again, so it'll come out as that. And then I've got tangent of theta, so that's going to be y over x. So here's my y, here's my x. So I've got negative 3 over 5. And then for the last three functions, so these are all actually just like the reciprocals of the previous functions. So I'm going to go ahead and just plug these in. If you want to pause the video here and just see if you've got these on your own, I would highly recommend you do that. Otherwise, I'm just going to show you the answer. So that would be the, you know, using these same relationships, this would be filling in the other trig functions. Okay, so if you want to see more examples like that, the one I just did, I have those also in another video, so I'll drop a link to that in the description. The last thing I want to talk about, I've kind of been referencing this, so thinking about positive or negative values of trig functions. So this is something that you're just going to get used to and you're going to develop an intuition with it. So I've got this example, suppose the point xy is in the indicated quadrant, determine if the given ratio is positive or negative. So it's in quadrant 3, and then I have this ratio y over r. Okay, so let's think about what this means. So quadrant 3, y over r. So quadrant 3, this is 1, 2, 3. So I have some point, I just drew a random point over here. So think about then, what can you say about the x and y values? I'm going to have, you know, this situation here, I kind of like create this right triangle. Well, I can see here the x value is going to be negative, as is the y value, right? So if the point's somewhere down here, these are both negative x and y values. But r represents a distance, so it's always going to end up being positive. So if I want to ask myself then, what about this y over r ratio? Well, y is negative, r is positive, so the entire value of this will be negative. And so that's just like you developing your intuition. You're going to do that a lot as you're moving through this, but we're just trying to get you used to that. And so otherwise, that finishes up this video. I'll see you guys in the next one.